In previous videos, we have seen how we can use the concept of the mole to convert back and forth between grams and moles or moles and grams. Now we want to build on that. We're really getting to the heart of stoichiometry, where we're going to be using mole ratios to switch substances within a chemical reaction. So what do I mean by that? Suppose you are given information about oxygen, but you're trying to calculate information about water. That's switching substances. In order to do that, you have to have a balanced chemical reaction. This is a combustion reaction. It has already been balanced for you. The mole ratios, these coefficients, become conversion factors that allow us to switch between substances. Mole ratios can be used to help convert between substances in a chemical reaction. Some examples of mole ratios. There are 5 moles of oxygen, that comes from the coefficient, for every 4 moles of water, also from the coefficient. Now that is a conversion factor that can be flipped. So I can write that with oxygen on top, or I can write that with water on top, just depending on how I need my units to cancel. Let's look at some examples. So here is my first stoichiometry example where I'm converting from moles of one thing to moles of something else within a chemical reaction. Here's the question. Using the chemical equation shown, how many moles of water can be produced when 2.05 moles of oxygen are consumed? So we are given 2.05 moles of oxygen, and we're trying to figure out how many moles of water will be produced. You always want to start with the number and the unit that you're given in the question. So 2.05 moles of oxygen is the first thing that I'm going to write. I'm in units of moles, which is great because when you're in units of moles, you can switch substances within a chemical reaction. Whatever unit I start with needs to go on the bottom of the next fraction. So moles of oxygen is what I started with. I'm putting moles of oxygen on the bottom of the next fraction. Now I'm going to use a mole ratio. I'm going to go from moles of oxygen to moles of water using the coefficients as my conversion factor. So this 5 became the mole value for oxygen. This 4, the coefficient for water, became the mole value for water. At this point, I'm ready to put things in my calculator. 2.05 times 4 divided by 5 gives me 1.64 moles of water. Oxygen has canceled out, leaving me with water as my answer. So I've used a mole fraction to switch from one thing to something else within a chemical reaction. Let's build on that a little bit. Suppose you're given grams of one thing and you're supposed to convert to grams of something else. This is more of a real life example because we have scales that can measure in grams. Okay, so here's the question. Using the chemical equation shown, how many grams of carbon dioxide's over here, can be produced when 8.45 grams of propane, C3H8, are consumed? So we're starting with information about the C3H8 and we're converting to CO2. So you always want to start with the number and the unit that you're given in the question. So 8.45 grams of C3H8. At this point, whatever unit you start with goes on the bottom of the next fraction. So grams of C3H8. The only place you can go from grams is to moles of the same substance. So moles of C3H8 goes on the top. Whenever you convert between grams and moles, your conversion factor is from the periodic table. 44.09 is the molar mass off the periodic table. That's adding up the masses of 3 carbons and 8 hydrogens. At this point, we're in units of moles of C3H8. We've canceled out the grams. Once you get to moles, you are ready to switch substances. So whatever unit I have here goes on the bottom of this fraction. So moles of C3H8 goes on the bottom. Moles of what I'm trying to convert to. The question wanted carbon dioxide. That goes on the top. So these numbers, this is a mole ratio. In a mole ratio, your numbers come from the coefficients in a balanced reaction. So C3H8 didn't have anything in front of it. That means it's a 1. CO2 has a coefficient of a 3. So those numbers become the mole ratio that allows us to switch from C3H8 to CO2. At this point, I'm in moles of carbon dioxide. That's great, we're in the right substance now, but the question wants grams of carbon dioxide. So we need one more step where whatever unit I have here goes on the bottom here. So I have moles of carbon dioxide here. I'm going from moles to grams. Whenever you do that, your conversion factor is the molar mass off the periodic table. So I'm going to add up 1 carbon and 2 oxygens off the periodic table. Notice that the molar mass was on the bottom over here and on the top over here. How did we know to do that? Follow your units. Whatever unit you have here must go on the bottom here. Whatever unit is here should go on the bottom here. And you should also be writing in your substances. C3H8 is going to cancel out grams of C3H8. Moles of C3H8 is going to cancel out moles of C3H8. The only time you can switch substances is in a mole-to-mole ratio. For every other fraction, your substances should match. Okay, so this is a full stoichiometry question where you're switching from grams of one thing to grams of something else. Here is that same example, that same setup that we just saw, but I've color-coded it for you. So you can see that the only fraction containing 2 different substances is the mole-to-mole fraction. I've got C3H8 in pink each time and CO2 in blue each time. In this mole-to-mole fraction, that's where I switched from C3H8 to CO2. Before that, everything was about C3H8. After that, everything is about CO2. So that mole ratio is crucial to switching from one substance to another substance within a chemical reaction. And the beauty of this is now labs become quantitative. At this point, you can do a lab where you put 2 things together and you can predict the amount of something that you're going to produce because we now know how to switch substances.